To this live streaming video. I'm so sorry, guys. Uh, the previous live streaming was in private mode. I'm sorry for that. Now, let's start this live streaming. Before I get started, let me check whether this live streaming is working or not on my phone. Okay, I see it. It is working. Okay. In this video, we're going to talk about merge sort sorting algorithms. In this problem, we're given an array. We have to sort the array using merge sort algorithm. We have this problem on LeetCode: sort an array. Given an array of integers nums, sort the array in ascending order and return it. We can solve this problem using merge sort algorithm. Let's talk about merge sort algorithm. In this video, let's see how to solve this problem using merge sort algorithm. Okay. Now I'm gonna start this. I'm gonna start right now. So in this video, we're going to talk about in details merge sort algorithm, how merge sort algorithm works, and everything all about merge sort algorithm. In this problem, we are given an array of integers. For example, let's assume we are given 4, 2, 5, 8, 6, 9, 1. If we are given this kind of array, unsorted array, we have to sort this array. We can solve this problem using quick sort algorithms. We have other sorting algorithms, but specifically in this video, we're going to talk about merge sort algorithms. Merge means we are combining something. We are merging something. Okay, we are merging something. So in this problem, what we will do, we will break our bigger problem into smaller problem. Then we will solve the smaller problem. When we cannot break down our smaller problem anymore, then we will start merging. In this problem, we need the concept of how to sort. In this problem, we have to understand, before we get started with this problem, you have to understand how to merge or combine two sorted array, or merge two sorted array. If we are given two sorted array, how to merge that, we have to understand this. Okay, this is a very simple concept. This is the prerequisites. This problem, merge to sorted array, is the prerequisites to solve this problem. Now let's see how merge sort works. You don't have to worry about recursions, all that stuff. If you are not confident in recursion, don't worry. In this video, I'll teach you how to solve a problem recursively. But if you know how recursion works internally, that will help you a lot understanding this algorithm. First thing, you have to understand how this algorithm works. So we have two parts in this video. In our first part, we will talk about the intuition. In the first part, we will talk about the intuition about the algorithm. Okay, how the algorithm works. And in the second part, we will code the problem using Java programming language. So this is the most important part, intuition or the algorithms, how the algorithms works internally. Okay, now let's see how merge sort algorithm works internally. For the sake of understanding, let's assume we are given this array of integers 4, 2, 5, 4 to 5, 8, 6, 9, 1. Okay. So for the sake of understanding, let's assume we are given this array of integers. Let's write out the index number. The index of 4 is 0, 1, 2, 3, 4, 5, and 6. All right. So we have an array. We are given an array. Okay. We have to sort that array using merge sort algorithm. Now, how merge sort works? This is our algorithms, and we have index number right here. This is the index, these are the array elements. Okay. Now we are going to we're going to detect a boundary. We're going to declare a boundary. This is left. Okay, this is left and this is right. This is left and this is right. Okay, I'm sorry. All right, so this is our boundary. Now what we're going to do, we are going to, our ultimate goal, we are given an array. We are given an array of integers. We're going to break it into two parts. We're going to break it into two parts. This is part 1, this is part 2. We are going to break our array into two parts. Then we'll take this part and we're going to break it again into two parts. So here again we'll get two parts. Then again we'll break this part, we'll get two parts, and we'll be doing this same task over and over until we cannot break the sub problem anymore. If you're not understanding what I mean by this, don't worry. Let's draw here a decision tree, so you will have a clear understanding. So first we have to partition this array, or we have to divide this array into two halves. How we can do that? So in order to do that, first we have to find out the middle. So we can find out middle equals to, we can say mid equals to left plus right divided by 2. So what do we get? If we calculate 0 plus 6 divided 2 equals to 3. So we get mid equals to 3. So what is our middle? Middle equals to this. Okay. Now in our we will have two parts, or if we partition, we get two part of this array. So we can say part 1. You can use any combination. We will take from left to middle, from index left to index middle, and in part 2, or in second portion, or this is for first portion, in second portion we'll have from mid plus 1 all the way to the right. Okay, so we're going to partition our array something like this. So if we partition, what we will get, let me show you that. All right, so here if we partitions, we get this array right here, 4 2 5 8. Okay, we get this array right here. This is our part 1. So we partitioned this array into this array, into two arrays. So this is our first partition, and let's write out here our second partition, which is 6 9 1. I'm sorry for the noise around me. I'm so sorry for that. Just keep your eye watching this video and try to understand. The first thing, what we just did here, we partitioned our array into two parts, or into two sections, we can say. So this is part 1 and this is part 2. This is what we just did. Nothing more than that. Okay, so let's write out the index number of this element. So 0 1 2 3. Then here we have 6 9 1. So 4 5 and 6. Okay, this is not a separate array. We will create a separate array. We will see how to do this. Okay, just try to understand. This is 4 2 5 8, and this is 4 5 6. Okay, now what we are going to do, we are going to partition this array again. We're going to partition this array into two parts again. All right, so let's partition. If we calculate part 1, we get from left to right. Middle is in this case 3 divided 2 equals to 1. So we get here middle. This is our middle. So in our left partition, what we'll get for 2 in our right partition. So you don't have to worry about the indexes. So don't be overwhelmed by the indexes. So let's remove them. Okay, so we get 4 2, and in our right partition, or in our right part, what do we get? We get 5 8. That's it. Okay, again let's partition this. If we try to partition this, what we will get? So let's try to partition this array again. So if we partition, what we get? we get this is left, this is right. What is the middle? So middle would be this would be the middle. So left to middle is 4. On the left partition we have just a 4, and in the right partition what we get just 2, nothing else. That's it. Okay, now at this point we see that we cannot break this subproblem anymore. Okay, so do nothing here. Then let's try to move to this direction, to the right partition. Can we partition this anymore? No, we cannot partition it, because we see we have only one element. We cannot break this subproblem into a smaller subproblem, since we find out this two subproblem in this level right here. So what we're gonna do, we're gonna just merge it here. The concept of merge to sorted array, this concept is required. If you know how to merge to sorted array, this is a simple algorithms how to merge to sorted array. So here if we just apply that concept, what we will get, we will just update this array. So we see that 4 is greater than 2, so we will have at this position 2 and here 4. So here we will have a 2, here we will have a 4. Okay, that's it. So we are done with this subproblem. Okay, we are done with this subproblem. Now let's move to this subproblem. We already solved this subproblem. Okay, now let's move right here. Same thing, same logic goes here. So we will have first in the left partition, in the right partition we will have only 8. Now we see we cannot break this anymore, so we're gonna just merge these two array. We can assume this is sorted because you have only one element, so we don't have to worry about that. So if we just sort these two, what do we get? And we will update in place this array right here. So what we'll get 5, 8. All right, so we solved this subproblem. We solved this subproblem and we solved this subproblem. So what we are going to do now, we are going to merge these two sorted array. We're going to merge these two sorted array. We can do that in O of n time complexity. Okay, so if we merge, what we will get? We can merge it using two pointer. That is very easy, very easy algorithms by using two pointer. Here we'll have a pointer, here we'll have a pointer. Using that pointer we can just merge this two sorted array. So what we'll get here a 2, here 4, 2, 4, 5, 8. That's it. All right, so we solved this subproblem. Up until this point we solved this subproblem. All right, so now let's move to the second partition. Do you see that we are calling, we'll call a recursive function, we'll call a function recursively, and we're breaking our bigger problem into smaller problem, and we are doing it in DFS manner. That means we are moving in one direction as far as possible. When we reach the limit, we are just exploring all possible route, we can assume, or we can say. Okay, this is the concept of merge sort algorithms. All right, now from here, from this portion, from this portion, what I would like to do, let's move to this right partition. All right, this is the right partition. Here we can break this problem. So if we break, what we get? All right, if we break this problem further, what we will get? Let's write out the index number here. So what we will have here, 4, 5, 6. So 4 plus 6 equals to 10. 10 divided 2 equals to 5. So this is middle. This is middle, this is left, this is right. So in the left partition, what we will have? 6, 9. All right. And again, if we partition this, let's partition right here. We will move in this direction first. This, then this, then this, then this. Okay. The kind of a DFS algorithm. This is a DFS algorithm actually. We are calling a function in DFS manner recursively. If you're familiar with the DFS algorithm, this is going to be easy for you, not difficult at all. But you need a solid understanding of recursion to understand this problem deeply. All right, so you don't have to worry about it. I'll show the code as well, and I will explain you how to work with this. All right, so here we have a 6 9. We can partition it. We get here 6, and here we will get 9. We cannot break this problem anymore. So what I would like to do now, we're gonna just merge it. Using the concept of merge two sorted arrays. All right, so if we merge and sort, we get this. Okay, so we solved this subproblem. Now let's move to this right here. So we have just only one element, nothing to do here. So this subproblem is already solved, I can say. Now what I'm gonna do, I'm gonna just merge this two sorted array. If we merge, what we get 1 6 9. So 1 6 9. All right, this is all. This is all we have to do up until this point. So we solved this subproblem. We solved this subproblem, and we solved this subproblem. So in this same level, we have this two array. This array, we will copy this array. We will have this array, and we will have this array. So we get this result, and we get this result here. We get two sorted arrays. So what I can do here, we can just apply here our sorting algorithms. We can apply our simple how to merge two sorted array. The concept of how to merge two sorted array. So this is all. This is the intuition of this algorithm. Now if we merge and sort, what we'll get, let me write out right below here. So if we merge, what we get, so first we'll get 1. So here we have 1 and 2, so we'll pick 1. Then let's move right here, 6 and 2, we'll get here 2. So we selected from here, so we'll move this pointer right here. So 4 and 6, so let's pick here 4. Then let's move to 5. 5 and 6, let's pick here 5. Then 8 and 6, let's pick here 6. Okay, let's move forward. This is 9 and 8 is minimum, so let's pick here 8. Then we have nothing on the right, but here we have 9, so we'll just copy whatever we have right here. So what we get here, we get this array, and we see this is a sorted array. If we see that we sorted our given array using the concept of merge sort algorithms. In merge sort, what we are doing, in merge sort algorithms, we are breaking our problems into a smaller subproblem. Then we're just merging the smaller subproblem. And from that concept, the word merge is attached to this algorithm, or we can say merge sort. So we are merging. Okay, so this is called a merge sort algorithms. We are first breaking our problem into smaller problem, and then we are merging the sorted array. Okay, and this is called a merge sort algorithm. This is all about this algorithm. Okay, so here the time complexity of this algorithm, the computation of time complexity is a little bit tricky. I have a video on this channel already, and you can skip the explanation part and just move to the complexity analysis part. You will see the time complexity analysis, how to compute the time complexity. We are breaking our problem into smaller problem each time. If we consider simply, we are breaking our problem into smaller problem. If you want a overview of time complexity, we are breaking our bigger problem. If this is our problem, what we are doing, we are breaking it into smaller problem. We are just dividing. We are making two halves. So we have this half and this half, or two parts. So each time we are dividing our problem into our subproblem into two parts. So from that concept, the time complexity is log 2n. This is 2 base log. This is not 10 base. Okay, we're dividing by 2 each time. So for dividing, it takes a log 2n time complexity, and we are merging our array. So for the worst case, we are merging something like n by 2 and n by 2. These two array. So this, if we have this kind of array to merge, if we have this. In order to merge this, we need linear time complexity. So we have to attach here again. So the time complexity is O of n log 2n. If you want to know how this time complexity is calculated or computed exactly, you can watch the video. I have attached I will attach the link to this video description. You can watch that. At the end of that video, I have explained how to find out the time complexity of Marshall algorithms. Alright, so that's it. That's all about it. Now let's talk about the recursion call and how this algorithm works. So first, we will have a function called something like this. So let's call it merge sort, M-E-R-G-E, merge sort. This function will take an array. Let's call it nums array. We will have a left boundary. Left is the index of our first element, and right is the index of the right element. Okay, this is our function. And right inside here, we'll call our recursive function. If we saw left is less than right. Okay, this is our condition. If left is less than right, we'll call our recursive function recursively. It means that we will call our function recursively if we have if we break our problem into smaller problem, and if we saw this subproblem cannot be break into any further. So left will point here, right will point here, middle also will point here. So in that case, we don't have to call our recursive function to break our problem into smaller problem, because we cannot break it anymore, right? And that's why we have this condition left less than right. And the interesting or the difficult parts coming right here. Don't worry, actually it's not too much difficult. And here we'll just calculate the middle. So left plus right divided by 2. To overcome the overflowing issue, we can use different formula. We'll show you when we'll write the code. Okay, and this is how we can calculate the mid. Here also you can use this formula. This is more efficient. Right plus left plus right minus left divided 2. This is more efficient because this will never have the overflowing issue. So we'll use this formula. We'll write the code. Okay, now here our recursive case for our left partition and a right partition. Do you see that when you have something like this, we have left partition and a right partition. So for left partition, we'll call our function merge sort. So merge sort from first, let's provide the number itself, then left boundary, or from left index, then mid. This is our left partition. For left partition, we'll call from left to middle, right? And for a right partition, merge sort nums, then from here middle plus 1, because we already included middle right here, so we have to call from middle plus 1 all the way to the end. All the way to the end, I means from middle plus 1 to right. This is not always just the end, because we are breaking our problem into smaller problem. And when we cannot break our subproblem anymore, what I'd like to do, we'll call our recursive function merge sort merge nums, then what we have, okay, left, middle, and right. So what do we do in this function? In this function, we'll partition from left to middle, then from middle plus 1 to right, and then we will merge that. Okay. We will have, when you call this function, we will have from left to middle always just sorted, and also from middle plus 1 to right is always just sorted when you call the functions. Okay, this is the core concept. This is the core concept of this algorithm, and we will implement this merge sort algorithm. In merge sort algorithms, what do? We just copied whatever value we have from left to middle and from middle to right, and then we're just merging it. Nothing else. That's it. This function is easy, but most of you will have difficulty understanding this code. Okay, this is a very simple recursive case. If we find out this condition, we'll call our function. We have a problem, we calculated mid, so we'll call here from left to mid, and right here from mid to right. That's all, nothing else. You don't have to worry about anything. We'll just call our function recursively. Recursion takes time to understand. In order to sink a recursive concept on your head, it will take a little bit of time. If you're a beginner programmer, don't worry. It will take a little bit of time to understand how recursion works. This is a simple concept, but it takes time. For me to grab the concept of recursions, it takes quite a bit of time, more than 1 year to be familiar with it. So don't be confused, just keep solving problem. You will see, you will understand eventually. So you don't have to worry about that. This is all about recursion. This is all about this algorithm merge sort. I hope you have a very good understanding of you will have a very good understanding of merge sort algorithms if you know if you watch this video. If you watch this video, you will have a very good understanding. Okay, I think this is all about merge sort algorithms. So we are dividing our problem into smaller problem. We're dividing by 2 all the way, just so the time complexity is log 2n. All right, and it will take n times log 2n time complexity. This is all. All right, and the space complexity is of n for the recursive call stack. Actually, for the recursion call stack, also we have to use 2 array to copy the partitions or the sorted array, or 2 left sorted array, right sorted array. We will see that. So the time complexity would be O of n, and space complexity is logarithmic. Actually, n times a log 2. All right, so I hope you've understood this video explanation. If you guys have any question, you can ask your question. I'm happy to explain. All right, let me check on my phone if you have any questions. I am happy to explain. Okay. I see there is no question actually. Okay, guys, so let me ask here. All right. Let me check whether we have any question or not. Okay, let me ask here. Okay, so do you have any questions? Okay, so if you guys have any question, ask your question. I'm happy to answer your question. Okay, I see there is no question, so we can move on coding part. Now let's implement this algorithm. The implementation is not difficult at all if you understand how this algorithm actually works. Okay. So I'm gonna take here presentify for screen annotations. Where it goes? Let me search. Oh, I got it. I'm sorry. This is this guy. Okay. All right. So now let's implement this algorithm. The implementation is not difficult at all if you understand the intuition. Okay, so I think this is, let's reset everything from here. I'm gonna use here a Java programming language. You can use any programming language you want, doesn't matter. If you understand the algorithm, that is okay. Implementation is not difficult if you know one programming language anyway. So here, first let's compute the left and right. Left and right. Okay. So int left equals to 0. Left is the index of our first element. Right equals to nums dot length minus 1. This is the index of our right element. All right. Now let's call a helper function merge sort. In this function, let's provide our array, then the index of left element and the index of right element. All right. At the end, when we are done with this function call, we will have another function call inside this function call. We will see that at the end, when we are done, we will have this array as sorted in ascending order, because we are passing the reference of this array. We will modify this array in place. Okay. Now let's implement this algorithm merge sort. All right. So right here, public. Return type is integer, merge, no return type actually, because we are modifying the array in place. So public void merge sort int nums, int left, int right. All right, so now right inside here, what we are going to do, right inside here, we're gonna check the condition if left is less than right. It means that if we can partition our array, or if we can divide, or we can break our current subproblem into further, if this condition is true, that means we can break our current subproblem into smaller subproblem. That's it. So if this condition is true, what we will do, we'll compute middle. Middle equals to left plus right divided by 2. But if the length of our array is too large, we might have some issues. So what I would like to do, because in that case, if we have a huge, if the size of array is huge, and we might have something like this: int max int divided to max int plus max int minus 1, something like this, divided by 2. So we'll have overflowing issue. We may have overflowing issues. So to handle this issue, we can use here a simple formula. This formula: left plus right minus left divided by 2. This is a safe. That's because it will handle the overflowing issue. So this is same as left plus right divided 2, because so right divided 2 minus left divided 2. So here we will have right divided 2 plus left divided 2, and so on. This is a simple logic. Now let's call this function merge sort. So merge sort. Now this is going to be for our left partition. This is for our left partition, we can say. So for left partition, nums we will have from left to mid. Okay, from left to middle. Now for right partition, merge sort nums from mid plus 1, because we have included mid right here in this left partition, so we cannot include here mid. So we have to start from mid plus 1 index. And here right. All right, this is for a right partition. Okay, now when we break our problem into smaller problem, if we cannot break our problem any further, what we would like to do? We would like to merge that. So merge here nums left mid right. So in this function, we're passing the reference of this nums to this function. So we have this index, we will have from left to mid already sorted, and mid plus 1 to right sorted. So we have to just merge that. No big deal. This function is going to merge the array element from left to middle and from middle plus 1 to right. Okay, that's it. It will just merge the two sorted array. This is the concept of merge two sorted array. That's it. No big deal. Don't be confused at all. So here we are dividing our array 2 by 2 because we are partitioning into two halves, actually, not equal halves. So here what we would like to do. So let's implement this function merge. Before that, we are dividing by 2. So this function, we can say, takes time complexity log to n time complexity, and here for merge it will take time complexity O of n. So the overall time complexity is n times log to n. Okay, now let's implement this function merge right here. This is just the concept of merge to sorted array. So public void return type is void merge, then int nums, then int left, int middle, int right. All right, so now right inside here, what we are going to do, right inside here, we are going to first find out the size of our left partition from left to middle, right? So let's call it int n1 equals to mid minus left plus 1. All right, then int n2 equals to right minus mid. So we find out the size of our array. This is for left partition, and this is for right partition. All right, size of left partition and the size of right partition. Okay, so you have to write you should write the codes that can be understood by someone. If they look at the code, they should understand what you mean by the variables and so on. All right, and right here, let's create an empty array of length n1 and of length n2. So int this is, let's call it left equals to new int n1. Okay, and int right, this is for right, new int n2. So here what we're doing, we have just partitioned our array. We have just partitioned our array right here, and here we're just merging. Okay, this is for left, this is for right, this is the size of left, this is for size of this right array. And now let's copy the value in our left array from left to middle, and to this array right from index middle to right. Okay, let's do it. So for int I equals to 0, I less than in1 I plus plus, and right inside here li equals to li. So let's do it in this line. So li equals to nums from our nums array. So I plus the left, because we have to copy in this array, let's call it left plus I. From left to, we have to copy in this array from the index left to index middle. All right, now right inside here int I equals to 0, I less than into I plus plus. Right inside here what we'd like to do, ri equals to nums. Nums here we're going to copy from mid plus 1 to right. So I plus, or we can say mid plus 1 plus I. All right, that's it. So we are copying the value from left to middle index in this left array, and in this array right, we're copying the value from mid plus 1 to right. That's it. No big deal. All right. Now what we would like to do, we're going to just merge these two sorted array. We know that this array is sorted. This array is already been sorted. We don't have to worry about that. So we have to merge those two sorted array. How we can do that? We have to apply the simple concept here. So we're going to apply here the two simple concept, how to merge two sorted arrays. Okay, that's it. No big deal. Now here what we're going to do, here we are going to just apply our simple formula. So int I equals to 0, j equals to 0. This is the pointer. I point will point to the first element of L1, L this left, j will point to the first element of right, and k equals to where we have to add our current element. We're gonna modify our array in place. We're gonna start from left index to up to the index right. Okay, so we're gonna just update that from left index to right index by sorting in place. We're not creating any extra array. We're not creating extra array. We're modifying our given array in place. All right, that's it. Right inside here, if you understand this algorithm, you will have easy time understanding the coding interview questions, popular coding interview questions like find kth largest element or kth smallest element. Actually not that, you can find out the number of conversions in an array. That's a famous coding interview questions, and for kth largest and kth smallest, you have to understand the quicksort algorithm, how that works internally. I'll create a video on that as well. But if you want to solve the problem like count conversions, how many count inversion, how many inversions we need to sort an array, we have to use this algorithm by modifying a little bit. If you understand how this algorithm works, then you can solve that problem easily. That's a famous coding interview question. The name is count inversion. How much inversion required to sort an array? Okay, I will create that coding interview questions as well. I will solve that in future. Now let's solve this. Let's merge it. So we'll store our element from left and right, from index left to right, in our given array nums. Okay, so in our nums array, we're gonna sort this left right, and we're gonna store from index left to right. Okay, here while I is less than n1 and j is less than n2, while I and j is valid. Okay, so here let's check I for L, right? So li, if it is less than or equals to right j, then what I'm gonna do, I am going to just I'm gonna add at kth index in our array. So nums k plus plus equals to the minimum is L1, li, right? So li, that's it. And also you have to increase it. And here else, this value will be increased when you updated the element at kth index, and it will be increased by 1 after copying the value, or after getting the value from I index. Only then it will increase. So you don't have to worry about that. Now right inside here, nums k plus plus equals to l j plus here actually r j plus plus. In this case, you have to take value from the r, because if this condition is false, that means rj is less than or less than li. That's why we have to apply this condition here, this logic right here. All right, this is our while loop. But if we may have something like this, if we may have something like this, we may have in our first array we have 1 2 3, and in our second array we have 5 6 7. So if we have something like that, I will point out of bound in this array. I will point out of bound, and j is pointing to this first element. J is pointing to this first element. So in that case, what we have to do, we have to copy whatever value we have from this array in our array. So in that case, we have to use here while loop. Also, we may have a case vice versa case, something like this. We may have this something like this and this, and we may have something like this 1 2 3. Okay, so in that case, we will see we will take all the value, but I is pointing here, so you have to copy this value to our array. So in that case, we have to check here while here while I is less than n1, while I is less than n1, here what I'm gonna do, I'm gonna just use a simple formula, this nums k plus plus equals to left I plus plus. That's it. So simple, right? While j is less than n2, same logic goes here. So nums k plus plus equals to right j plus plus. That's it. This is our sorting algorithms. And this function takes time complexity, linear time complexity. It will work in linear time complexity. This function takes time complexity logarithmic, because we are dividing. When you call this function takes O of n time complexity. So the overall time complexity of this function is O of n log n log n time complexity. In log n time complexity. This is a 2 base log. Okay. This is our algorithms. I hope you have understood this video explanation. Merge sort algorithms. Let's use these annotations right here. Now let me explain here a little bit. This is for our sorting, merge to sorted array. This is the algorithm for merge to sorted arrays. Simple algorithms right here, and here we're just copying the value. We're just copying the value from left to middle, then from middle plus mid plus 1, from mid plus 1 to right. Okay, and then here we have this function merge sort right here. All right, we're just calling this function recursively. We're breaking our bigger problem into smaller problem right here. Okay, by this function, this is for left and this is for right. This is for right. Okay, that's all. I hope you've understood this video explanation. Now let's run this code and let's see if it passes the test cases or not. If we find out anything wrong, we will fix that. Let me check whether it will. Okay, accepted. Let's submit it now. All right, accepted. We have solved this problem successfully. Guys, if you have any question, you can post your question. If you have any issue understanding this code or any line of code, you can post your questions. This is a super important question to solve the problem count inversion. That's a famous coding interview question. Okay, so let me check if we have any questions. Actually, no questions I saw. No problems. Yeah, that's all for this video. I think you've understood the sorting algorithm, merge sort algorithm in details. Okay. Now I'm gonna stop this video right now. I think you have understood this video explanation on a very high level. If you have any question, you are requested to ask your question on the comment on this video. All right. Now I'm gonna stop this live session right now. Thanks for watching. Thanks for joining in. If you're new to the channel, subscribe to the channel. If you want to ace your coding interviews, I'm practicing coding interviews. It will help you a lot. So if you want to start problem solving, and if you're not understanding how to start, what to do, and some other factors related are important while solving problems, so I will share everything with you. So you are requested to ask any questions if you have any questions. All right, thanks for watching. I will see you in another live video. Thank you very much.